Hey everyone, in this video we're going to go over data structures fan from Codeforces round 895, division 3. So let's go through the problem statements so we understand what's happening. So first we get a string of length n, okay? It's a binary string, so it's only zeros and ones. And then we have an array of numbers, length n. So there's two types of queries. So type 2 is when they ask us, so when they either give us 0 or 1, right, for type 2, and whichever number they give us, let's say they give us 0, for all the elements, all the array elements that have 0 index or inside string s, wherever the index, wherever the index equals 0, so this guy, this guy, this guy, this guy, we're going to do a XOR on all of them and we're going to return the answer, okay? Same for 1. So that's type 2 of operation. Type 1 operation is it gives you two numbers, left and right, so you flip all the bits between 2 and 4 inclusive, okay? So this would become this, right? So those are the two types of operations. So obviously we shouldn't do a brute force approach because this and this could be very long, so it would be n square, and this is 10 to the 5, so this is 10 to the 5, so it wouldn't work out. So you can do n square algorithm. So it has to be better than that. So the key observation, this property, there's this property of numbers, which is any number XORed with itself is 0, okay? And that's the key property. That's what we're going to use to solve this problem, right? So what we're going to do first is we calculate the XOR 0 and XOR 1 separately. So let me show you the code so it makes sense. Wait, not this. Sorry. Yeah. So here we take input, we get the string. This is a query. So first we pre-compute the current XOR for all the 0 elements and all the 1 elements, okay? We do that just in case, like in this example, they ask us 2 0 and 2 1 before even doing a type 1 operation. So we want to be ready for that, basically, right? After that, we also maintain a prefix array. So this is the key observation, which is maintaining a prefix array. If you know what prefix sums are, basically prefix sums is like, if you have an array, say 1 2 3 4, the prefix sums are basically 1 3 6 10. So you keep track of the sum until from the start to this index, okay? So in our case, we are doing something similar, but instead of keeping the sum, we're going to keep track of the XOR, okay? And essentially whenever they give us two indices like left and right, so in this case they give us 2 and 4, we can actually, what we can do is we can do prefix of right XOR prefix of left minus 1. What is this actually doing is we are prefix of r is essentially doing XOR from all elements 1 to r, and then if you XOR them with all elements 1 to L minus 1, you can kind of cancel out the L minus 1, because if you remember this property, if you do XOR with the same number twice, it's same as doing nothing. So in fact, the effect this has is XOR from elements L to R, which is what we need, okay? And why would this work, you may ask, right? So let's say in the example above, so we had 1 0 0, which becomes 0 1 1. So essentially all the numbers, so we want these three elements, right? So which is 2 3 4 in the array above, okay? So essentially before 2 belonged to the set 1, now it belongs to the set 0. So first what we can do is get rid of 2 from ones, okay? How do we do that? Ones already contains 2, so we do 2 XOR 2, so that's the same as not doing anything with 2. So now if we want to, for these guys, it was not in the array before, but now it's in it. So we want to have the effect, so the 3 is not in 1, but we want it to be. So this is so that's why this has the effect of simply adding 3 into the XOR, okay? Same for 4, because it was not there before, so if you just XOR it with it once, it's like adding it into the XOR set. Now the same goes for 0. So before, this guy is not in 0, okay? Before 2 was not in 0. So if you do XOR 2, it's actually adding it to the set. Before, 3 was in 2's, 3 was in the 0 set. So if you do it again, it's the same as not doing anything. Okay, same with 4. Oh, this is actually computing the power. I don't want that to do that. 4 XOR 4 equals 0. Does that make sense? So that's the effect. So essentially, we pre-compute. Here are the steps. Pre-compute 0 and 1 XOR sets. XORs. 2. Whenever one type 1 operation, we just compute prefix of L XOR prefix of sorry, it's not L, it's R and prefix of prefix R, prefix of L minus 1. This is equal to taking XOR from elements L to R, and then we take this thing, let it be equal to cur. We do 1 XOR equals cur, 0 XOR equals cur, and this will maintain the set. Whenever type 2 operation, just return either 0 or 1 depending on the input. So that's all we need to do. And if you go back to the code, that's all I do really. So we compute the prefix sums. If it's type 1 operation, we compute prefix R, L minus 1, we do XOR on 1 and 0, and then whenever we get the number, if it's 0, we output 0, if it's 1, we output 1. So that's all. So the main idea is using prefix sums and this key property of XOR, which is, if you do it twice, it's the same as not doing it. So yeah, that's it. Thank you guys for watching.